Algebra 1-1, Unit 1, Pretest Notes, otherwise known as Unit 4 in the Pantheon of Algebra at Crestview. Brain tease, what's the next number in the sequence? You're looking for patterns and you're looking at the consistent difference. You're adding 2 to each number in this sequence of numbers. So that means the next numbers would be 14, 16, and 18. 55, 48, 41, and 34. What's the next number in the sequence and why? It's 27 because you are subtracting 7 from each number. 55 minus 7 is 48. 48 minus 7 is 41, and so on. What is the actual sequence for this row of numbers? 6 to 11, 11 to 18, 18 to 27, 27 to 38, and 38 to 51. What is our sequence? What happened? Well, to get from 6 to 11, you added 5. From 11 to 18, you added 7. From 18 to 27, you added 9, and so on. So you're adding an odd number to each one of these numbers in the sequence. But between each odd number, starting at 5, you're adding 2. So the pattern can be multi-layered. Is this a function? Squiggly line? Not a function. Circle? Not a function. The L shapes? Yes, those are functions. The straight line? Yes, it's a function. And the V shape? Yes, that is a function. Choose the ordered pair that is a solution to the equation represented by the graph. You've got ordered pairs, you've got a graph. You're just seeing which one of these ordered pairs actually fits onto the graph. Well, here is our 0 minus 3 point. Our 0 minus 3 point. And then here's our 2, 0 point, our 2, 2 point. None of those actually fall on the line. None of those actually fall on the line. Our answer is D. Our answer is D. Negative 3, 0. 1, 2, 3, 0 falls directly on our line. What about our next one? The ordered pair that is the solution to the equation represented by this one. So you've got our graph. Is 1, 3 on the line? Well, starting at 0, if you go over 1 and then go up 3, yep, that ordered pair is on the line. So do we need to check negative 1, 1, 2, 3, not on the line, or negative 4, negative 3, not on the line? Our answer is A. The domain of a function is the complete set of possible values of the independent variable. In plain English, that means the domain is the set of all possible x values which will make the function work and will output real y values. So when you're finding the domain, remember, the denominator of the fraction cannot be 0, and the number under the square root sign must be positive. What you should remember is all the positive values for x. So think, what's the lowest value x can be, and what's the highest value? Well, from the left side of the function on the graph, that's a -9. That's the lowest value represented, and the highest value was the 7. So your domain of the function, -9, is less than or equal to x, which is less than or equal to 7. -9 is your lowest value, 7 is your highest value, and we're talking about the values of x. What about for this particular graph? What is the lowest value, i.e. the lowest number on the left? And what is the highest value, the highest x value on the right? There's our negative and positive numbers. -4 and +4. So the domain of this function is -4 is less than or equal to x, which is less than or equal to 4. Remember, this is all about counting. You start at our center point, -1, -2, -3, -4. Here's where that ordered pair was, right here, at 0, -4. And on the opposite side, 1, 2, 3, 4, +4 or 0 or 4, 0, that was our highest ordered pair here. What is the minimum value for this graph? Well, we're still looking at domains of functions. However, we want to know what is the minimum value in terms of our y-axis. So basically, it's a U shape. What is the very lowest point on this particular function? Well, that's right here. Keep in mind, this graph is going by 5, so when you're counting, keep your numbers in mind. -1, -2, -3. There is our point, the lowest point of this particular function, so that's our minimum value. All other values are going to be higher than -3. On the flip side, what's our maximum value? Again, you look for that highest point on this shape, which is there. And that's 1. It's at the 1. So that's our maximum value. All right, so we've got another function here. It's nicely curved. The graph to the left shows the graph of y as a function of x. The rate of change for y as a function of x is non-constant, meaning it's not the same. This function is nonlinear because the graph is not a straight line. It curves. So here are two things to know. That if your rate of change for y as a function of x is non-constant, meaning it's not the same, it's going to be nonlinear. And it's nonlinear because, as you can see, it curves. It's not a straight line. Now, the y-intercept of this graph is the function value y equals 8. So at our ordered pair 0, 8, that's where the function crosses the y-intercept. And y-intercept is just your y value, up for positive, down for negative. Where does this function cross that y line? At the number 8. And for all values of x, the function value will be y greater than or equal to 0. Here's an easy one for you. Again, we're still talking about functions, but functions in real life. Renee can afford to spend a total of $90 on his daughter's birthday party. What is the maximum number of guests he can invite? Well, take a look at our graph. So we're just now in coordinate 1. So we're talking about positive numbers because we're talking about positive amounts of money being spent. Along the bottom, you have the number of guests from 0 to 100 and the cost from 0 to 100. Making it easy, each box is worth 10 going both along the x-axis and along the y-axis. We want to know how much he can afford to spend if he only has $90. Well, if no one shows up to the birthday party, he's spending $40. That's because that's how it's notated on the graph, but we want to know about $90. So you look at your costs, go up to 90. How many people can he invite? Take 90 all the way over to where you can see that function. Put in your point, bring it all the way down. 50 guests. 50 guests. So we're going to talk through this table. The table below identifies the values for the first 5 terms in an arithmetic sequence. Our term number in 1, 2, 3, 4, 5. Term number is increasing by 1. The term value starts at 5 and then goes 5.5, 6, 6.5, 7, 7.5. What is the increase in value from left to right? Here it's 1, here it's a half. For every 1 increase in term number n, the term value an is 1/2. The lowest real number is 5. For every 1 increase in our term number, the term value a of n is a half, 5.5 to 6 to 6.5, with our lowest real number in our term value as 5, because we're starting at 5.5. So basically, you can pop it over and put it into a chart. So instead of going left to right, it's going from top to bottom. So you can look at these relationships. So if you had to write an equation that can be used to find the value of a to n, the nth term in the sequence. So if we wanted to know the 10th term or the 15th term or the 5,412th term, how do we figure that out? Easy. Our a of n, that term value, is 1/2 n plus 5. 1/2 n is because we have that 1/2 difference between each of our numbers. That's our pattern, adding 1/2. Our lowest whole number is 5. So to check that out, we can just add, say n is 1. 1 times a half is a half. Add that to 5, you get 5.5. If our n is 2, well, 2 times a half is 1, plus 5 is 6. So anytime you have a function, you can always check to make sure it's right by taking this top number here, however it's designated, and popping it into whatever the interval is at the bottom, and making sure you're coming up with the correct answer. The graph of the function f is shown in the coordinate plane below. Here's our coordinate plane. Here's our function f. A table listing some of the values of another linear function g is shown. So here you have a graph and you have a table. So to make this easier to see, I just took this function from this graph and I put it in a table so it's side by side. Our question is, which of the two functions, f from the graph or g from the table, has the greater absolute value of the rate of change? What you're looking for is the increase in value for f, this function, versus g, this function. Well, our x values don't change. They're increasing by 1. Easy peasy. Over here, our function f of x, we start at 2, go to 2.5, to 3, to 3.5. What is the change here? What is our pattern? For every 1x, this is decreasing by a half, or minus 1/2. What about over here? 0 to 1, 1 to 2, 2 to 3, it's changing by 1. But over here, we're going from 9 to 6, 6 to 3, 3 to 0. What is that pattern? For every 1x, our g is decreasing by 3. So when you have to compare these two, which is the highest number? What is the greater absolute value for the rate of change? Function g, because it's changing by 3, and 3 is bigger than a half. How are the three pictures related? Explain using a function. This is simply a counting thing. How many blocks are going from left to right versus how many blocks up? Just count the blocks. So each row of blocks has 6, and then you have the 1 extra. Well, what about here? We've got 2 rows. Still 6 blocks per row, plus 1 more. And in our third picture, we still have 6 blocks, 3 rows of blocks, plus 1 more. So for every 1 row of 6 blocks, there is plus 1 block to the height. So for our rows, our function would be 6 plus 1. For our first picture, we have 1 row of 6, 1, 2, 3, 4, 5, 6, plus 1 additional block. Here we've got 2 rows, so we have 12 blocks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, plus 1. Right? And for our third one, we end up with 18 blocks, 3 times 6 plus 1. So our function is, our function of r being the rows, 6 times the number of rows, 6 because there are 6 blocks per row, plus 1, our additional. What is the domain of the two functions? Here we go. The function of ft is 7.2t, is the average distance in kilometers Jason rides his bike over time in t hours. The function of gt is 5.9t, is the average distance, gt, in kilometers that Maria walks over time in t hours. So t is all about time. T is the time in hours. So basically, boom, we know that both of them are moving. He's on a bike, she's walking. So the time must be equal to or more than 0 hours, simply because they're moving. So if you had to compare the rate of change for both Jason and Maria, what does this tell you about Jason and Maria's speeds? So think, how fast are they going? Well, it says that Jason is going 7.2 miles per hour, and Maria is going 5.9 miles per hour. Jason is moving faster. 1, because he's on a bike, and 2, because our function tells us that he's moving at 7.2 is his average distance in miles over t, time in hours, and 7.2 miles per hour versus 5.9 miles per hour. So is there a time when their distances are the same? Yes. By using factoring and like denominators, the questions ask for the same distance. If Jason's distance is 7.2 miles in an hour and Maria's is 5.9 miles, you can multiply the two numbers together to get a like denominator. That is the distance, the first distance that will be in common between them both. It would take Jason 5.9 hours to hit that distance of 42.8 miles, while it would take Maria 7.2 hours to travel 42.8 miles. Now, the question is quite nebulous when you see it on the test. It is quite nebulous because it's kind of open. Is there a time when their distances are the same? Well, let's take a look at B. They could also reach that same distance, and for this I'm just using the top distance of 7.2 miles. And that is the distance if Jason waits for 0.22 of an hour, or basically 1/5 of an hour. That way, at the 1 hour mark for Jason and the 1.22 mark for Maria, so approximately 1 1/5 of an hour for Maria, they will both have traveled 7.2 miles. It takes Maria 1.22 hours and Jason 1 hour to hit that 7.2 miles. So their distance would be the same, it's just the amount of time it takes them would be different. With B, I calculated that they end up at the same distance at the same time. Jason has to wait for Maria because Maria walks slower. So if Maria started out at, say, noon, Jason would have to wait approximately, 1/5 of 60. Jason would have to wait about 12 minutes or so, or 0.22 of an hour before he can start out. That way he would reach that 7.2 miles at the exact same time as Maria. Both A and B are correct answers. They're simply answering two different questions. And that's because this original question is very vague. Y equals 3x plus 5. Which of the following scenarios would be described by y, our answer, equaling 3 times a number plus 5? A, the distance of a tortoise from the starting line in a race. If the tortoise started 5 miles ahead of the starting line and moved at a pace of 3 miles per hour, your time per hour would be your x. The amount of money Miranda has if for every $5 she earns, she gives 3 to her mother. That's a subtraction problem. The number of cards Larry has if he had 3 collector's cards and he adds 5 more cards to his collection every 3 days. Well, that would be 3 plus something with a multiplier. D, the number of points earned on a test if each question is worth 5 points, but Mr. Felder subtracted 3 points for every incorrect answer. This is not a subtraction problem. So what say you? Y equals 3x plus 5, A, B, C, or D? A, our correct answer is A. Which of the following scenarios could be described by this equation? Well, we have our x at 0, 2, and 3, our function of x, 0, 25, and 50. Is this even linear? Yes or no? It's not linear. So A and B are definitely not our answers. Why is it not linear? It is not linear because our function of x does not increase by a constant amount compared to x. It is not linear because our function of x does not increase by a constant percentage compared to x? Well, take a look at our chart. We're not talking about percentages, we're talking about patterns. So our answer is C. This parabola, that's our little U shape, f of x equals x minus 2 to the second power plus 1 is graphed here on our xy coordinate plane. Now, our vertex of our parabola is 2 units right of the origin and 1 unit up from the origin. The origin is always 0, 0, and that plus 1 tells us the x-coordinate. Remember, x runs left to right, y runs top to bottom. This particular graph is by tens. So here's our 10 mark, 2, 4, 6, 8, 10. Always keep that in mind. That is why it's saying it's moved 2 units to the right, because we're counting by twos. Our vertex is just that point, the highest or lowest point on your parabola. This is a counting problem. This is a function of x plus 3. How does it compare to x minus 2 to the second power plus 1? How does it compare? Well, it goes from 1 and a half to 0, 2 and a half at the origin. Fx plus 3 has a horizontal, meaning left-right, shift of 3 units to the left of our function of x. Here is our origin, 0, 0, 1, 2, 3, 3 units to the left, whereas this parabola, if you recall, was 2 units to the right and 1 unit up. That's how it compares. When you're comparing, you're just showing how it's alike and how it's different. Why is that function true? G as a function of x equals x plus 2 squared. First, what are the 4 points on the function on our graph? What are the 4 points on this parabola? We've got 0, 4. We've got negative 1, 1. We've got 0, negative 2, 0. And we have negative 4, 4. I picked those functions because they are simply the easiest ones to see. If we put those in a nice handy-dandy chart, we find that that particular graph function is true because when we put our x values into that, we get our y value. For example, if x is 0, 0 plus 2 is 2. 2 to the second power is 4. That gives us our 0, 4. If I put negative 1 into our x value, negative 1 plus 2 is 1. 1 to the second power is 1. That gives us this point here. If I put in negative 2 as our x value, negative 2 plus 2 is 0. 0 to the second power, 0 times 0 is 0. That gives us this particular point here. Choose easy and obvious numbers that you can see on the graph. You're proving that this is true by simply taking our x values, the easy numbers you can see, popping them into this equation. Our y values is the answer. This is true because our function of x equals x plus 2, then squared, is true because when 0 is used for the x value, 0 plus 2 equals 2, and 2 squared equals 4. If negative 1 is added to 2, it equals 1, and 1 squared equals 1. The following is the graph of f(x) equals x squared. Why is it true? Again, pick 4 points on our function graph. Again, I picked super easy points. 2, 4, 1, 1, 0, 0, and negative 2, 4. Those were the easiest ones to find. You plug them into the formula and solve. 0 to the second power is 0. 1 to the second power is 1. 2 to the second power is 4. This is function f of x equals x squared, or times itself, because 0 squared is 0, 2 squared is 4, and 1.5 squared is 2 1/4. Yes, I went there and looked at using 1.5, going up and seeing, would I really land at 2 1/4? And indeed I do. Our next one, why is this true? Our function g of x, which is our y value, equals x minus 2 squared. Choose easy and obvious numbers, 0, 2, 3. That's where our little parabola actually crosses our x and y lines at a point that's easy to see. Our function of x, when x is 0, 0 minus 2 is minus 2. Minus 2 squared is positive 4.
Teachers and staff, I wanted to thank you guys so much. I sent an email out to you just recently. Because of that, I would like to let you know, make sure if you have everything caught up that you guys will have a great weekend, and we'll see you Monday.
If we put 2 in, our x value of 2, 2 minus 2 is 0. 0 squared is 0. So we've got a 2, 0. This is function g of x is true because when you put 0 in for x, 0 minus 2 equals minus 2. Minus 2 times minus 2, or minus 2 squared, is 4. 0, 4. Why is this one true? The actual math is already done for you. The answers to your math problem is your coordinate xy, your xy coordinates. Plug them into your table first. This will help you solve your equation. Function g of x is the absolute value of x minus 1. Why is this one true? Take a look at the coordinates that I gave you. Look at where those numbers fall. So y is a function of x, meaning your y value, equal to the absolute value of x plus 1. The function of x is the absolute value of x plus 1. The math is already done for you. The answers to your math problem is the xy coordinate. Plug them into the table first, and that will help you solve your equation. Here is a graph of two functions, f of x and g of x, where g of x equal f of x plus h are shown. You're like, oh my God, what? It's okay. Again, this is a counting thing. How many blocks between the two y values? You want to figure out what is h. You don't know where to start. Well, check it out. If the function f of x and g of x are your y values, what are the coordinates of each y value, meaning going from your top to bottom, up and down? Well, our f of x function, f is 0, 0, because it's right here in orange. It starts at 0. Well, but for g, it starts at 0, 5, 0, 5. Based on the graph and our coordinates, what is the value of h, or that distance between the two y values? 5. Why? Because that's the difference. 0, 1, 2, 3, 4, 5. That's our difference between the two y values. That's our h. How about this one? The graph of two functions bx, b for blue, and ox, o for orange, where our ox equals bx plus h are shown. Based on this graph, what is the value of h? There's a lot to unpack here. So if your function b of x and o of x are your y values, what are the coordinates for each y value? What are the coordinates for blue, b? What are the coordinates for o, orange? Our b of x function is 0, 6. Easy enough. 0, start at origin, and we just go straight up to 6. For orange, start at 0. You have to go all the way down to -9, down here. So based on the graph and the coordinates, what is the value of h, or the distance between our two y values? You're counting from 6 all the way down to -9. Our h is 15. 15 is the difference between our two y values. All right, so basically that is all you need to know. These notes will be in our Google Classroom. Please, please, please do this first before you take the test, and read over your notes. Thank you so much.